All right, welcome folks. Today we're going to get going with our AP exam review, starting with going through the 6 common question types you're going to see on free response questions. Okay, free response is really a free-for-all where technically they could ask you about anything from the course, but in general there's kind of 6 themes that are going to show up for you year after year. Now, those 6 themes can kind of blend together and mix together here. What we'll do just for kind of instruction purposes is look at a few cherry-picked questions that kind of fit the themes nicely and use that to kind of get our AP exam review kicked off for us here. Okay, question type number 1 for this video, we're talking about the rate and accumulation question. Now, in some way, shape, or form, AP exam time, you're going to get a free response question that talks about a rate. Okay, it could be a rate in, could be a rate out, could be both. And the big idea is the amount of stuff at time t is the initial amount plus what was added minus what was removed. Okay, so this type of question is going to involve some integrals, okay, accounting for the initial conditions. Okay, it could be subtracting if we're coming out, adding if we're coming in. Again, we'll give you some examples. All right, and then key formulas that show up on a question like this is our kind of amount function, where the amount at a time t is equal to the integral of the, we could say, rate in minus rate out, if we have both those parts. Okay, plus that initial condition, so taking that into account. Now, if I'm talking about the amount at t, we could also find a rate of change by just setting that derivative equal to the rate in minus the rate out. Okay, we'll be able to work back and forth between these two a little bit. And then also, this is a common question type where the extreme value theorem comes into play, where we want to find an absolute min or max. Okay, and they occur at either critical points, where our rate in equals rate out, okay, and the endpoints. Okay, so we'll talk about that candidates test determining mins and maxes. Okay, all great stuff that doesn't have to show up on this question, but typically does when we're talking rate and accumulation. All right, so let's take a look at an example from the AP exam. And here we're going to go with year 2000, number 4. Okay, oldie but a goodie. Again, I tried to cherry pick some examples that really hit the heart of this question type here without mixing in some other stuff we'll review as we go through the rest of the reviews here. Let's take a look. We've got water is pumped into an underground tank at a constant rate of 8 gallons per minute. Okay, water leaks out of the tank at a rate of root t plus 1 gallons per minute for t between 0 and 120 minutes. And then also at time t equals 0, the tank consists of 30 gallons of water. Okay, so a pretty typical situation we've been in through the semester where we've got a rate in, we've got, we'll color code some stuff here, a rate out. And then also, we know kind of our initial condition. And kind of keeping that stuff in mind will be what we need to kind of work through these different questions. All right, part A says how many gallons of water leak out of the tank from time t equals 0 to t equals 3. Okay, so leaking is going to be dealing with our rate out here. Okay, we have the rate that things are leaking. If we want to get the total amount of leaked, okay, going from a rate to a total, that's going to be an integration question. Okay, going from a total to a rate would be derivative. Rate to total is integration. So this problem is just going to come down to taking the integral from 0 to 3 of our leaking function, root t plus 1 dt here. All right, so evaluate that, and that's going to give us the total amount leaked from t equals 0 to t equals 3. Now, something to consider is we're leaking. Okay, so are we subtracting this? Here we're just looking for a total amount leaks. We'll give it a positive answer, but something to consider as we go through the rest of the problem. All right, so if I want to integrate this guy, now this is on the no calc part. If it's on the calculator part, we can just plug this into our calculator and move on. But no calc, so we got to do this by hand. I'm going to say this is going to be a simple U substitution question. Before I can deal with this t plus 1, I've got to kind of substitute it out so I can use my reverse power rule. So for that, I'm going to say u is equal to our just t plus 1. And this will be a pretty simple u substitution. In this case, our derivative of u with respect to t, du over dt, is just the derivative of t, which would be a 1. Okay, plus derivative of 0, which is a 0. All right, so in this case, du is just equal to dt, so we can just make a straight up substitution there. All right, so I can rewrite this as the integral from, now let's plug things in first. We could say square root of u du. Okay, with the t plus 1 taken care of with the u, dt taken care of with the du. Now I also want to get in the habit of adjusting my limits to integration when I make a u substitution. Right off the bat, when we're going from 3 to 0, that would be a t equals 0 and a t equals 3. We switch things up to u here, and we define u as t plus 1, so that means that we'd have a u equals 0 plus 1, 1 in other words, and u's equal to the 3 plus 1, 4. Okay, we'll take care of that right now, just so we don't have to substitute that t plus 1 back into our expression when it's all said and done. Okay, so let's integrate. Now I guess I lied. Before I do that, let's rewrite this in terms of exponents instead of roots. So I'm going to rewrite this as the integral from 1 to 4 of u to the 1/2 power du. Okay, just because I've seen this enough where I kind of have it memorized, but I'd much rather switch to this form so I can use my reverse power rule. Now remember what that is when I'm finding antiderivative of a variable to a power. We could say in general, when we have the antiderivative of x to the n dx, that's going to be equal to 1 over n plus 1 x to the n plus 1. So in this case, what we'd have here is u to the, when I go 1/2 plus 1, that'd be 3/2. And as far as this piece, what I'd have, the n plus 1 will be the same thing, 3/2. Now 1 over 3/2 is just the same thing as 2/3. All right, so there's our antiderivative, and we're going to evaluate that from u equals 1 to 4. So to finish things off, we'll just plug in that 1 and 4 here. So this will be a 2/3, and I suppose I'll just leave that in parentheses here. Okay, times 4 to the 3/2 power. I'm going to rewrite that as the square root of 4 to the 3rd. All right, minus same thing, square root of 1 to the 3rd. All right, so we've got our antiderivative. We substitute things in. Now, since we're on the free response part of the question, we can actually quit here. This is fine. Okay, free responsers don't make you take care of the arithmetic unless it's a calculator question where you do have to round. Okay, so we could leave it like this. Now, just because I'm going to actually reduce this and take care of it, because I believe in part B, we're going to need this answer again, or we could need it again. It'll make life a little easier if we simplify this down. But anytime on free response questions, if you are worried about making an arithmetic mistake, you can just leave things the way they are, like we see here. Okay, so this would be a 2/3. The square root of 4 is 2. 2 to the 3rd is 8, so it'd just be an 8 minus square root of 1 to the 3rd would be a 1. Okay, so I've got a 7 times 2/3. We could rewrite that as 14/3. And then what are we talking about here? We're talking gallons. Okay, that's in the problem, so I probably don't need to include it, but to be safe, I'd say gallons when it's all said and done. All right, do I need to explain what that means at all? Nope, that's pretty straightforward in the question here. We just want to put the answer with the label on it, okay, for our final solution here. Now, as we go through these questions, we're also going to pull up the scoring rubrics just to kind of talk about how a question like this would be scored on the exam. Like we've said, you're not going to be perfect. You're going to make mistakes. We just want to show you how things are scored just so as you're going through, you might not be able to get the answer, but if you can get some of the points when it's timed on exam time, okay, that's good enough to get a pretty darn good score. Okay, so this question here is worth 3 points. And there's kind of 2 different ways we can approach it. We stuck with method 1 here. Now here, I'm going to get a point for the limits and the integrand. Okay, so in other words, just by setting up this integral, I'm going to get a +2 if I can get that right. Now as far, and I suppose, whoops, my pen went wonky on me there. Let's clean that up a little bit. There we go. Now, as far as what exactly we mean by the limits and the integrand, I'd have to look closer at the scoring guideline to see kind of exactly what I need for those. But either way, what you can tell with this is just by setting up that integral, interpreting my situation, the question we're answering, and turning that into calculus, I get a couple points here. Okay, for the rest of the point, we've got the answer. Now for that, I would need to get to this part correctly. If I quit anywhere here, like we said, I'd get another +1. Now, trick is if I do make a mistake with my substitution, with my actually taking the antiderivative here, if I goof anything up, I'm not going to get this point. Okay, so do be careful with kind of the steps to get from integral to antiderivative. But as long as I get to here, I do get that 3rd point. Good example of a question where I might make some mistakes, but I can still get 2 out of the 3 points, which puts me on a pretty good spot for this question in general. All right, moving on to part B then, pretty quick question here. How many gallons of water are in the tank at time t equals 3 minutes? Okay, notice that 3 minutes, we're going to utilize the answer we have up here for this one, which is why I have them both at the same time here. With the free responsers, sometimes the next piece moves on to something completely different, but in certain cases you do need to use previous answers. Okay, so what we're looking for is, I'm going to say A of 3, the amount in the tank after 3 minutes here. There's going to be 3 things that's made up from. First thing is going to be the initial condition. At time t equals 0, we have 30 gallons. So that's just going to be a 30. Okay, plus, we want to think about what came into the tank here. And my rate in is pretty simple. It's just 8 gallons per minute. So I'm going to write that as just an 8 times 3. Okay, 8 gallons per minute times 3 minutes. Now, if I really want to make this look calculus-like, what I could do is I could go the integral from 0 to 3 of 8 dt, which would be equal to an 8t evaluated from 0 to 3, which is just the same thing as 8 times 3, the 24 there. Okay, so if we wanted to go there and add that in, we could, but a little bit simpler. We're going to use some kind of arithmetic. All right, and then we've got our rate out. We want to go minus what we lost from the tank from time 0 to 3, which is just this 14/3 gallons. All right, and again, I could actually stop here before I do my arithmetic. Good habit to be in is if you're pressed for time, just leave the arithmetic and move on. Just because we're a math teacher here, we're going to actually take care of this. It's not too bad, but if you ever get to a spot where you feel like I might not need this answer again, I don't need to clean it up, here we kind of was nice to clean up from here to here, but you can always leave it where it's at. What would we have here? We'd have a 30 plus 24. That's going to be a 54. Okay, minus that 14/3. Okay, which would be equal to, if I want to put this in terms of thirds, I'd have 3 times 54 would be a 150, 162. minus the 14 thirds. Okay, subtract, and that's going to give me a 148 thirds, and we're talking gallons. All right, again, that's my cleaned up answer, but there's nothing wrong with leaving things right here, because again, you don't have to simplify arithmetic on the AP exam. Now, the scoring for this part's pretty straightforward. Part B, 1 point. You get a point for the answer. So as long as I get to here, I'll get the point for this question. Now, this is an example where if I missed my answer on part A, I could not get the point for part B. Okay, the actual test will mix things up where you don't need to move forward with certain answers. You start fresh, and other times you do. Okay, so a good example of where be careful on these integration steps, because we're going to use that point again later. Okay, so in this case, we get the +1, okay, for having that final answer or any unsimplified version of it. All right, so moving on. Next question, part C. Write an expression for A of T, the total number of gallons of water in the tank at time T. Okay, so now here we're going from part B, where we found the amount at a specific time, to a general formula to give us the amount in the tank at any time. Now, it might seem kind of backwards. Wouldn't we want to find this equation first, and then so we could apply it to part B? Yeah, that'd make more sense, but as far as scoring-wise, the exam wants to see, can you kind of use the idea to find something specific first, and then we'll get into the higher stakes, more difficult problem to find the general piece here. Okay, so technically we could work backwards and use this to check our answer for part B, but we'll assume we're good with that part. All right, trick with this one is we don't know anything about A of T besides the initial condition. We do know something about A prime of T. The rate at which the amount of water is changing, well, that's just going to be equal to the rate in minus the rate out. So 8 for the gallons per minute coming in, okay, minus square root of T plus 1 for the gallons coming out. All right, and the way I'll get from here to A of T as opposed to A prime of T is we'll just integrate both sides. I suppose technically I want to cram my D, whoops, we're not talking X, we're talking T in on both sides. Okay, so when I take the integral of a derivative, I get just the normal function. I'll have A of T is equal to, and then I just have to take care of this integral on the right side. Now, splitting this into two parts, the integral of 8 would just be an 8t. So easy work there. And then minus, we'll also have to take the integral, the antiderivative of this piece, that root t plus 1. Now, this will be a similar u substitution of what we already did. We can say u is equal to t plus 1, meaning that du is just equal to that dt. All right, so I'm going to rewrite this as an integral for this part. It's okay to split these up and do them separately. That'd be the integral of u to the 1/2. I'll just write that right away here, du. All right, and before I move on, I want to make sure I remember a plus c. We're doing antiderivatives here, so we will have to account for that initial condition. All right, so rewriting, we've got A of t is equal to 8t minus, this is going to be, we've already done this one before, reverse power rule. It'll be a u to the 3/2 power, okay, multiplied by a 2/3 plus that c. All right, so in other words, A of t is equal to, we could say 8t minus that 2/3, and then I will need to substitute this u back in here, and I could rewrite that as a radical. It'll be a square root, because we have the 2 on the bottom, t plus 1, all to the 3rd power, plus the c. All right, so there's my general antiderivative for this function here. And when we look at scoring, we'll see that we get a point so far for this piece. Last thing we need to do to complete the problem is figure out what's going on with this c here. For that, I'm going to come over here. We can use our initial condition at time t equals 0. So when t equals 0, we'd say a of t is equal to 30. So I know that it is 30 when 8 times the 0 minus 2/3 square root 0 again for the t plus 1 all to the third plus c. Now be careful substituting back in. In a lot of cases when we're using t equals 0, everything cancels and we just get c is equal to that initial condition. Notice that's not going to be the case this time. I'll have 30 is equal to, yep, the 8 times 0 is just a 0. Okay, but this second term's not going to cancel out. What we'll have is a negative 2/3 times, when 0's here we have a 1, square root of 1 to the third is just a 1, so in other words times a 1 plus c. Okay, so in other words, adding 2/3 to both sides, we end up with c is equal to, could leave it as 30 plus 2/3. That'd be fine. Again, we don't have to simplify that arithmetic. Again, if that's driving you nuts, though, we can simplify it. What would we have here? We'd have 90/3. Okay, so that'd be 92/3 for my final value of c. All right, putting that all together then, we can say that for a final answer, our a of t is just equal to that 8t minus the 2/3 square root of t plus 1 to the third, all right, plus the 92/3 for this one here. All right, then finally scoring this guy, we'll just slap the rubric piece up here in the middle. There's 2 points to this question. 1 point for finding the antiderivative with the c. So 1 point for getting to this point here where we just have the plus c. And another point for finding that c, plugging it in, getting that final answer here. Okay, so another good example of if you can do some calculus but just struggle with some of the uglier, maybe algebra to kind of get that c by itself, you can still get a good chunk of the points there.